Hello everyone, I welcome you all to Startup Academy, your online gateway to success in ISS exam. This academy is exclusively for ISS and we have been covering the topic sampling techniques in which in the previous lecture we discussed about the topic Des Raj estimator. Today we'll do that, and there are two methods in Des Raj estimator. First one is the case where two units are drawn from the sample, and the second one is the case of general where n number of units are drawn. So the in our syllabus only first one is there, so we'll discuss that only on this channel. And for the general case we'll skip that because we are uh, sticking sticking to the syllabus only. So let us begin. So let us say that let y1 and y2 be the value of units ui1 and ui2 drawn at first and second draws respectively. First point is this, we'll consider this. Second point is let P1 and P2 be the probabilities, or we can say initial probabilities of drawing the units ui1 and ui2 respectively. So these are the these are the two notations we can say that we should keep in mind, and ui1 and ui2 can be used interchangeably as well. Suppose ui1 is not exactly drawn at first draw, it can be drawn at the second draw, and so on. So we are discussing this Raj estimation estimators. Here we are discussing case 1, and we'll only discuss case 1, not 2, because that is not in our course. So case 1 is when two units are drawn. So in this case, let us consider the estimators as first one will be, let us consider first estimator z1, which is nothing but y1 upon np1, or we can say it is small np1. And the second estimator is z2, which is nothing but 1 upon n y2 plus y2 upon p2 upon 1 minus p1. This can be written as 1 upon n y2 plus y2 into 1 minus p1 upon p2, where we can say that p2 upon 1 minus p2 is the conditional probability of conditional probability, we can write it directly, which is probability that ui selection of ui2 when ui1 has already been selected. Selection of the second unit when the first unit has already been selected. And one more estimator is there, which is z bar. Z bar is nothing but the average of these two estimators, z1 and z2. So in Desraj estimation, what do we have to analyze? We have to analyze that this z bar, estimation of this z bar should be an unbiased estimator of the population mean. This is our whole case. In PPS WR, in both the cases, Lahiri's case and cumulative sum case, we have calculated this only, and in this method also, we have to calculate this only. So now our estimation of population mean. Which is given by y bar, right? So in estimation of population mean, for we have to analyze that estimation of z bar, which is the mean of the two estimator, is nothing but equals to population mean, or z bar is an unbiased estimator of population mean. So we know that analyze that estimation of z bar is equals to population mean. We know that summation I goes from 1 to n, or this should be capital N, pi, probability of selection of ith unit, is nothing but equals to 1. So we'll take z1 first. Z1 was nothing but 1 upon n was y1 upon n p1. So estimation of z1 can be written as estimation of 1 upon n y1 upon p1. This 1 upon n is constant, it will come out, and we are left with estimation of y1 upon p1. Now this y1 upon p1 can take can take any value from n values, capital N values which are present. It can take any values from n values. It can take y1 upon capital P1, that is first unit. It can take y2 upon capital P2, or it can take yn upon capital Pn. It can take any of the values from this. So estimation of z1 can be written as 1 upon n estimation of y1 upon p1. This can take values from that, so we can write it as estimation of 1 upon n. First value can be y1 upon p1 into probability of selection of p1 is p1, plus second value is y2 upon p2 into probability of selection of p2 is y2 is p2. Then the nth one is yn upon pn into selection of probability of nth term is pn. So if we take that, this is nothing but 1 upon n into this p1 gets cancelled with p1, p2 with p2, and pn with pn. So it will be y1 plus y2 up till yn. So this will be 1 upon n, summation I goes from 1 to n, yi, and it is nothing but equal to y bar. And hence we can say that estimation of z1 is equals to y bar. Let us mark this as equation number 1. Now we'll calculate the estimation for the second one, which is estimation of y2. First of all, we'll see what is y2. Sorry, z2. Z2 was 1 upon n y2 plus y2 into 1 minus p1 upon p2. This was z2. So estimation of z2 is given by 1 upon n. 1 upon n comes out because it is constant, and we are left with estimation of y2 plus y2 into 1 minus p1 upon p2. Now, we know that one of the properties of estimation, suppose we are taking estimation of x, this can be written as estimation of x into estimation of y given x. This formula can be taken like this. So we can write this as estimation of z2 equals to 1 upon n estimation of, we can take estimation inside, and we are left with estimation of y2 plus y2 estimation of y2 plus e1 e2 of y2 into 1 minus p1 upon p2 given x. Given that first unit has already been selected in the first row, that first row has already been taken place, and this is the probability of selection of the second row, where E2 is the conditional expectation after fixing the unit U1. So we can say where E2 is the conditional expectation after fixing U. Okay. So now we can say that we'll take this expectation on the next page. So we know that E2 by 2 upon P2 can take any n minus 1 values except for the first value. Except for y1 upon p1, because y1 upon p1 has already been selected with value as yj upon pj having probability yj upon 1 minus p1, because the total probability gets divided by because p1 has already been selected, so we will take 1 minus p1. So this expectation of z2 can be written as expectation of 1 upon n into expectation of y2 plus e1 e2 of y2 into 1 minus p1 upon p2 given ui1. So we can take 1 minus p1 out from here. This can be taken out, and here we are left with y2 upon p2 given this. Now 1 minus p1 can be written here on the outside. So y2 upon p2 given first drawn has already been taken place. So we'll directly put the values of this here. So we'll get expectation of z2 is nothing but equal to 1 upon n expectation of y2 plus 1 minus p1 into if expectation we are taking expectation of y2 upon p2 given ui1. So the values become 1 upon n expectation of y2 plus 1 minus p1. Now expectation of y2 upon p2 given y1 is nothing but equal to summation over j goes from 1 to n. We are left with p. What was the probability? The probability was yj upon 1 minus p1, yj upon 1 minus p1 into the value was yj upon pj. This probability was not yj, it is pj. It is pj. So this pj and this pj will get cancelled. This 1 minus p1 and this 1 minus p1 will get cancelled, and we are left with 1 upon n expectation of y2 plus summation j goes from 1 to n yj. Now this summation excludes the first unit. So this can be written as 1 upon n expectation of y2 will be y2 only plus this summation of yj can be written as y total minus y1 minus y2, which has already been selected. So this y2 and y2 has been cancelled, and we are left with 1 upon n into y total. This is nothing but equals to y bar, which is our population mean. So we can say that estimation of z2 is also equals to population mean. Hence this becomes our equation number 2. So we have to calculate the estimation of z bar. Z bar is nothing but z1 plus z2 upon 2. So taking the expectation of z bar, we can say that it is expectation of z1 plus expectation of z2 upon 2, which is equals to y bar from equation 1 and y bar from equation 2 upon 2, which is equals to 2y bar upon 2, which is equals to y bar. And hence we can say that Z bar is an unbiased estimator of population mean. This is what we wanted to prove, and this is what base large estimator is all about. That this our estimation becomes unbiased estimation of population mean. So this completes your topic. This completes your estimation and topic for today. In the next lecture, we'll be doing the variance of the same topic, and that will complete your topic on the whole. I hope that you have been continuously working on the examination and continuously watching the lecture videos. If you have any doubts in today's lecture or even the before lectures, then you can ask in the comment section, or you can ask in our on our WhatsApp channel as well. Only relevant doubts will be answered. And keep on working hard. All the best. Thank you.